In this video, we want to review the commutative properties. I like to think of the commutative property as having the word commute in it, so we can move things around. That's what these properties are about. So let's look at an example. For addition, if I write 2 plus 3, we know I have a number line right here. The meaning of that is that I should go 2 units to the right, and when I have finished doing that, I should go 3 more units to the right. Hopefully we all know that gets us to 5. But the question that the commutative property raises is, does 2 plus 3 equal 3 plus 2? And I think it's pretty clear that if we went 3 units to the right and then followed that up by going 2 more units to the right, we would end up in exactly the same place. So we can conclude, we could do this for any number of examples and see that it's true. So the answer is yes. So we can say addition is commutative. Okay, now let's consider a second problem. Let's consider the problem 3 minus 2. Does that equal 2 minus 3? And I think clearly the left-hand side is 1. And the right-hand side is -1, and so we could give that an emphatic no. So what does this show us? This shows us that subtraction is not commutative. Let me highlight not commutative. But could we make the subtraction problem into a problem that is commutative? And the answer is yes. Any subtraction problem can be turned into an addition problem because subtraction is simply the opposite of addition. So if I rewrite 3 minus 2 as 3 plus the negative of 2, then we can commute it because this would be equal to the negative of 2 plus 3. On the number line, what this would be telling us is that 3 minus 2 would mean we want to go 3 units to the right, followed by 2 units to the left. I'm sorry, that would be what 3 minus 2 represents. It's exactly what 3 plus the negative of 2 would represent. We would go 3 units to the right, followed by going 2 units to the left. If we were to instead turn around and go 2 units to the left, followed by 3 units to the right, we end up at exactly the same place. So 3 plus -2 is equal to the -2 is equal to -2 plus 3. So if we turn the subtraction problem into an addition problem, we can make it commutative. Now let's consider what happens if we want to do multiplication. So let us consider an easy example. 3 times 2 and 2 times 3. We, I think, can pretty clearly say that these two sides are equal. So we would say yes, 3 times 2 does equal 2 times 3. Multiplication is commutative. In fact, you might find it useful to think of this in terms of boxes. Okay, so a 3 times 2 would be like having a 3 by 2 box. And if we had a box that was 3 units tall and 2 units wide, we could say that the area is 6. If we turned around and made another box that was 2 units wide or tall and 3 units wide, its area would also be 6. So 3 times 2 is equal to 2 times 3. Now, what if we turn this around? Let's actually switch to numbers, slightly different numbers. Let's see what happens if we do division. Does 4 divided by 2 equal 2 divided by 4? And the answer to that problem is a clear no. Okay, because 4 divided by 2 is clearly 2. 2 divided by 4 is equivalent to 1/2. So the answer is no. So we can say division, which I've expressed as a fraction in this case, is not commutative. As you move along in math, you'll rarely write things like 4 divided by 2. You will usually write 4 over 2 as a ratio, and that means the same thing. So division is not commutative. Could we make it commutative? Let's see. So the answer to that is yes. If I rewrote this as 4, instead of divided by 2, dividing by 2, we're going to later talk about, is the same as multiplying by 1/2. So could we say, if we change this to 4 times 1/2, we could say that that is equal to 1/2 times 4. And if we put a question mark here, we could say that is a definite yes. So just like for addition and subtraction, we can change subtraction problems into addition problems. We can also change division problems into multiplication problems so that we can take advantage of the commutative property. A final note, if I have multiple things like 3, I should say more than 2 things, 3 plus 2 plus 5, I think we can quickly convince ourselves is the same as 5 plus 3 plus 2. So we can move things more than one, the terms can move around by more than one place, and it's still commutative. And likewise, 3 times 2 times 5 is equal to 5 times 3 times 2. So if we have more than 2 things, we can still apply the commutative property to multiplication. In fact, it's kind of neat to think of this, the multiplication as a box. We could have a box that is 2 units high, 3 units wide, but extends 3-dimensionally back by 5 units. Now, since we have 3 dimensions, 3, 2, and 5, we don't get an area anymore. We would get a volume that is equal to 30. If instead we turned around and had a box that was 5 units tall by 3 units wide in the front, and then only extended back 2 units, it would have exactly the same volume of 30. So this would be 5 units tall, 3 units wide, and going back 2 units. In fact, we could take the first box, and if we rotate it up on its end, we could have a picture of the second box using exactly the same box. So they're going to have exactly the same volume. So multiplying in a different order does not give us a different volume.